contingency table. Because if you look here, what are we talking about here? We're talking about someone can either be on time, someone can either be late, someone can either be what? Be absent. But at the same time, someone can either be a boy, someone can either be what? Be a girl. You see that? Okay? So what do we have then? We have a situation whereby we are going to be talking about boys who are on time. So you say, when you say boys and then you say on time, where these two meet here, you have an intersection. What does that represent? It represents boys who are on what? On time. So how many boys are on time based on this table that we have here? How many boys are on time? There are 40 boys who arrived on time. Okay? How many boys are arrived late? How many boys arrived late at school? It's 18. Okay? So we have late and then we also have what? Boys. But how many people are late in total in that particular week? How many people were late in that particular week in total? The what? How many people were late? Again, if we go to late, we just concentrate on this one. If you go across, then you're going to be talking about people who are what? Who are late. This is the total number of people who are late. How many females does the school have? How many girls does the school have? How many girls does the school have? The school has 35. They have 35 girls. Okay. We have things that can occur at the same time, and then we have things that cannot occur at the same time. A row and a column can occur at the same time. Two rows cannot occur at the same time. It's possible for someone to be late and then on time at the same time. Is it possible for you to be late and then you're on time also? So you see the rows themselves, they are mutually exclusive. Because it's not possible for someone to be late and on time. It's not possible for someone to be on time and be absent. It's not possible. Did you get what we're saying here? And then, yeah, even boys and girls, the columns also, they are mutually exclusive events. What do I mean by that? I agree, it's either someone is a male or someone is a what? It's a female. Someone can either be a boy or someone can either be a girl. We should be careful with these things. Someone can either be a boy or Now, with that aside then, we have our sample space. What is the total number of learners that were in the school? How many number of learners were here? There were 100 learners in the school. Okay? Now we can then start to talk about the probability then. Probability. The probability, actually, it's how many ways can that event occur all over the sample space. Now let's check here on number 8. They say calculate the probability of a learner arriving late for school. So what are we going to look for? Late for school again. Arriving late, here's late. How many people arrive late to school? There are 25, right? So the probability that someone will arrive late, we're going to tell them what the probability that someone will arrive late is going to be given as 25 all over the total number. What is going to be the total number? It's going to be 100. Now this is 25 all over 100, which makes it to be 1 all over 4. Which is going to be 0.125 if you want to. Does it make sense? Does it make sense? So far, it does make a little bit of sense. Eh? Okay, let's look at this then. Calculate the probability of a learner arriving on time. How many learners arrived on time? Regardless of their gender. Everyone just asking, how many learners arrived on time? Regardless of whether they are males, regardless of whether they are girls, regardless of whether they are boys, doesn't matter. How many people arrived on time in this particular school? There are 65 people who arrived on time. So what is the probability that someone is on time? It's 65, okay? All over 100. Okay? What is going to be 65 all over 100 if you do that? The probability that someone is on time, you say is going to be 0.65, like this. Are you sure? 0.65. 0.65. Yes. Guys, it's not my answer, it belongs to C. Let me make it clear so that if it's wrong, I didn't punch the answer. Let's try this one, number C. Calculate the probability that the probability of a learner being absent if the learner is a boy. So here we want someone who is absent and is a boy. We want someone who's absent, okay? And the person is also what? A boy. Do we have something like that? What else are we looking for? We're also looking for a boy. Okay? So we're looking for boy and absent. Boy and absent. How many people are boys and they're absent? Boys absent. The probability of, you see this one is like I'm going to say which it's B and. You see that one again? It's B and absent. So the probability that it's a boy and it's absent is going to be 7 over 1 over, which is going to be 0.07. Is it 0.07? The answer is 0.07. Usayizwa makindabani. Silasise. Le landelayo ngiphe wena. Calculate the probability of a learner arriving on time. So the first event that we're looking for is arriving on time. Okay? Arriving on time. If it's and arriving on time, if the person is a what, it's again. So we want arriving on time and again. So we want to, let's use a different card. So we want girls and then we want on time. This is where they meet. How many people satisfy the condition in which there are girls who arrive on time? How many are girls who arrive on time? There are 25 of them. So on number D, if they ask us how many are girls who arrive on time, we'll tell them it's simple that one. Number D, the probability that someone is a girl and is OT. OT is on time. The probability that we have a girl on time is going to be equal to 25 all over 100, which is going to be 1 all over 4. Or you can write it in decimal, doesn't matter. Okay, this one is fine. Okay, now you understand. You said now you understand. What are we looking for here? We are looking for number E, calculate the probability of a learner arriving late. So go and highlight late here, just late. Okay? Go to late, that's the first event. Oh, different story, okay? It's arriving late or being absent. Okay? So we have arriving late or being absent So these are the two. There's no intersection between these two. You see how did I do it? I'm looking at the two events that they're talking about. Okay? Arriving late, I go across. Being absent, I also go across. Okay? So there's no intersection. Now, what does it mean? It means being late and absent, they are mutually exclusive events. What do you know about mutually exclusive events? What can you tell me about mutually exclusive events? They cannot occur at the same time. Okay? If they cannot occur at the same time, what does it mean mathematically then? On number E. It means with the probability of A. In this case, we have the probability of being late. Okay? So we'll call it L and being absent. The probability of being late and absent. Okay? What is going to be the probability of being late and absent is going to be equal to what? To 0. Why is that? Why is this probability of being late and absent being equal to 0? It's because again, when I went like this, there's no place whereby I intersect with these two things. So we are looking for or. How do you get L? We have a formula for calculating or. Okay? What does the formula say for calculating or? It says the probability of being late, okay? Or absent. Probability of being late or absent is going to be given by the probability of being late plus probability of being absent, okay? Minus the probability of being late and absent. We know this one, okay? Probability of being late and absent, we know it. Okay, let's go and write this then. What are we going to have then? We have probability of being late. How many learners are late? There are 25, okay? How many learners are absent? It's 10. So what are you going to have here? You're going to have something that looks like this. Probability of being late, it means you're going to have 25 all over 100 plus 10 all over 100 minus 0. Why 0? Where does the 0 come from? We don't have a situation of someone being late and absent. A person is either they are late or they are absent. They can't be late and absent. It doesn't exist. So what are we going to have then? We're going to have 35 all over 100, okay? Which is going to be equal to 0.35.